everyone, and thank you for attending my session. My name is Khalida DOUIBI. I'm a data scientist and a machine learning researcher. I will be talking about a new emergent technology about the brain-computer interface, and we will discover together in this talk how could this technology be applied to several fields. But before starting, I would like to share this beautiful quote from Edward de Bono, who said, "The human humor is by far the most significant activity of a human brain." And I would like to say that it is true that what we can see in general in our brain activity is our humor activity or attentional or emotional activity or our way actually to think or to solve problem. However, the question is, could we use this brain activity to interact with our environment, to control some external devices? So in this talk, we will be trying to answer this question if possible. So before starting, I would like to talk a bit about me. I am a data scientist, and I would like to highlight that I'm not a neuroscientist. I am PhD in biomedical informatics and passionate about new technologies, data science, and machine learning. I like really to create some decision support system to experts and discover in some insights from the data, and especially to help patients in to live better actually. And I like to do like operational research and innovation and create some useful tools with the new technologies for the industry. In my talk, I will be talking about the new emerging technologies. What is the brain-computer interface technology? And then what are the main applications of this technology that could be applied in several fields? When we talk about the new emergent technologies, I think it is really important to talk about the previous and the evolution of the previous technologies. And I will be starting by the apparition of the keyboards and mouses to control some devices and the PC. Then the graphical user interfaces to improve the way how to interact with this those devices, and then the apparition of mobile computing and the multi touch to use like our mobiles, and then the apparition also to of conversational interfaces like Google Home, Alexa, some those assistants that give the user the possibility to interact with his environment with his voice. And then we all used for sure the technology of XAR, X reality. So the augmented reality, the virtual reality, or mixed reality. And I don't know for you, but for me, I'm always asking myself, like, what will be the next? What will be the next technology that could be used in several fields? And according to this great report from Reply, about a human machine interfaces trend report, they said that the next new emergent technology will be the brain computer interface. And the good news is that I will be given more information actually about this technology during this talk. So what is this brain computer interface? So brain computer interface actually is a field between the neuroscience and medicine. And the main application or first application were for clinical applications to help some patients with disabilities. And the brain computer interface, which means when we use our brain activity to interact with our external environment. So the idea is how to use or how to measure this activity, and we can use several types of measurements. So there is a non-invasive measurement like electroencephalographic, where the user can make a BCI headset or EEG headset, connecting some sensors on his head, and we collect or we measure this activity. There are some solution which we call invasive BCI, which means we do like some surgery to put some sensors inside the brain of the patients, and it is used mainly for clinical applications. So once this brain activity is collected, we use some feature extraction methods to extract some useful and relevant information for this brain signal, and that we call the biomarkers in neuroscience. So then those feature of interest will be classified using, for example, machine learning or deep learning or signal decomposition methods to classify and to just try to understand what the user wants to do in his environment. For example, he wants to move a machine, to control an external device, or to move his processes, etc. And I want to highlight also that there are many types of non-invasive BCI. So we have three types mainly. So the first one is active BCI, which means the user should try to imagine like an activity. So for example, he wants to move his arm, so he starts to thinking about moving his arm, and then we treat like the signal, and we detect which and we detect that he wants to move his arm actually, and we can show to the user, for example, an avatar who who move his arm. And the idea behind that is that we can use that for rehabilitation, especially for patients who are attended of post-stroke problems. And then the reactive BCI, which means we show to the user an external stimuli, which could be visual or auditory, and then the user starts to focus on those stimuli. And when in the signal, we try to detect those like the stimuli that where the user was gazing, let's say. And the passive PCI, which means that the user didn't use any movement or any thoughts, let's say, and we collect passively his EEG signal, and we try to measure his state actually, if he's stressed, if there is a fatigue, if he's workloaded, etc. So it is more about the mental workload. So now let's see where we can use this actually this BCI, and I try to categorize those applications on six categories. So the first one is some clinical applications, mainly used in the literature. Then in education and training, how could we use this technology? And then games and entertainment, security and authentication, neuromarketing, and I would be talking a bit about, could we use actually this technology for the industry? I will be trying to ask this question too. So the first clinical application that is really useful for some patients that has like post-stroke, and it is a way to neurofeedback, so to show the user his biological activity, and it is a way of rehabilitation, or for example to help him to see his activity of sleep, and to improve actually his sleep quality. So the first what you can see here in the first picture, that the user is wearing a BCI headset, so we collect with those sensors like his EEG brain activity, and he is thinking about moving his arm. He is he has like a post stroke, he can't actually move his arm. However, he can see on the screen that he can actually, and there is his brain is um, already like active, and he can move his arm, and this way we can rehabilitate this patient. Another applications in clinical, which is the assistance. So we can use the BCI for communication, the assistance for communication. For example, for spellers. So we show to the user a screen, and which is a reactive BCI. So we show some flickering icons with the letters, and the user can gaze on those icons um, to spell or to write a word or a sentence. And then the second one is navigational assistance. So we can use actually for some patients who can't move or something like that. We can use an exoskeleton who can do the action or the motor for him, movements for him. The second field is the education and the training, and the idea is how to adapt the learning according to the personal performance. So, according to the brain activity, we can discover that the user, for example, he is maybe the training is more. Like we should have like the less speed, let's say, for the learning, and adapts the learning process according to his brain activity. So the third field is the gaming and entertainment. So there are a lot of works that are interested and on how to use the brain computer interface activity for gaming, and especially for virtual reality gaming. So where the user wear a BCI headset and he can play or interact with his virtual environment. And another other researchers are thought about how to create like a group of a game, but in with the two players or more, and they play only with their brain activity, so no movement, no vocal control, etc. So another applications is the smart home. So imagine that you are in a smart home and you are using like your brain your brain activity to control your devices inside your home, or maybe to adapt your there is an adaptation, let's say, of your environment, luminosity, etc., according to your mental load or mental state, if you are stressed, etc. So which is very interesting and passionate, actually. So another field, there are some researchers who are interested about the security and authentication, and how to use the brain activity as a bio, let's say, like biometric, let's say, to identify the person, and to identify the person, and we can use it like for security and authentication. Another fields used that's where the BCI could be used is the neuromarketing. So we can actually maybe study like the preferences of the user according to his brain signals, and we can do like some consumer profiling, etc. So uh, I will give like this notes of for the conclusion. So as you see, like there is a growing interest in those application of BCI in several fields. So we show it in our talk, like the deployment of BCI applications, particularly in rehabilitation, neurofeedback, monitoring, the mental state of user, for example, device control, new marketing, training, and other fields. However, so the big question is if the society will accept actually those this technology, and mainly, so there are mainly some challenges to be addressed before, like some ethical challenges, societal challenges, ergonomic and technical challenges. So because for now this technology is in laboratories, so the big question is how to do to bring this technology outside the laboratories to the industry, to the operational use. and if the user actually accepts to use his brain signal or brain identity to several applications. So what I say that for future work on my our project actually in my company, so we are working on how to use the brain computer interface for applications in Industry 4.0. So for further question, I would be really glad to get in touch with you. So please email me on this email or connect with me on LinkedIn. I'm very active and I would be really happy to connect with you. So some upcoming events if you are interested about the technology. So I will be having like a conference, Brain Info, which is a neuroscience conference about the application of BCI for Industry 4.0 in July. And we submitted a new scientific articles that address the main application for Industry 4.0, but in depth we talk about what are the main challenges and how could these challenges be addressed. So at the end, I would like to thank you very much for your attendance. Thank you. And don't hesitate if you have some questions. Mhm. So Simon said you are showing very good visual to explain what can feel complicated in BCI. Yeah, actually, this technology is very complicated, and as I highlighted, like it is more about the acceptability of this technology in our real world applications. Let's say. So this is a very interesting and exciting. Thank you very much, Hafef. Ethical and emotion AI within BCI. It's an important topic. Perfect. Yeah, actually, FF Neuralink. Yeah, I think they are working on technology. Does this technology have bad effects on brain health? Actually, no, no, because we can. I'm not a neuroscientist. I'm not a medicine. But if you are using like non-invasive BCI, you are just collecting like the data from the brain of the user, and actually it depends on the task because our like the neuroscientist creates a task to see some useful information, let's say from the brain activity of the user, and then those information will be treated with the data scientist, etc. So it depends actually on the task that you create for this from the brain activity of the user. I think there are no more questions. Thank you very much for your attendance, and let's connect on LinkedIn. Thank you.